Hi everyone. So in this video, we'll see about comparison of CSI and VSI. That means current source inverter and voltage source inverter. So already we have discussed earlier videos about closed loop control of voltage source inverter and closed loop control of current source inverter. So here we will summarize the uh, we about CSI and VSI. So already we have seen current source inverter is more reliable than voltage source inverter, right? The conduction of two devices in the same leg due to commutation failure does not leads to sharp rise of current through them. So it has inherent protection against a short circuit across more motor terminals. So this is the comparison of VSI and CSI in the point of reliability. So in VSI will have the commutation failure and and also short circuit problems. That's what VSI is not reliable. So and also VSI is not popular due to these two reasons. Next one. Next, second one is because of large inductance in the DC link and large inverter capacitors, the CSI drives has high cost, weight and volume, lower speed range and slower dynamic response. So the inverter LD, so you are using in CSI instead of VSI. That's what the cost of the CSI drive is more, and weight also will increase and volume also will increase um, compared to the VSI, right? Lower speed ranges and slower dynamic responses are the CSI drives are not suitable than these applications. So these applications like low speed range and slower dynamic responses. So voltage source inverter VSI drives are suitable. Next one, the CSI drive is not suitable for multi-motor drives. There is a one disadvantage in CSI. So in these cases, multi-motor drives are there. So we have to go for voltage source inverter drives. So hence each motor is fed from its own inverter and rectifier. A single converter cannot be used to feed a number of VSI motor system connected in parallel. So a single VSI can similarly feed a number of motor connected in parallel. So here what we can summarize here, CSI is not suitable for multi-motor drives. So VSI you can use for parallel drives, that is a multi-motor drives. So these are the comparisons of the CSI and VSI. So this is one of the important. Sometimes they may ask to write explain the advantages and disadvantages of VSI and CSI. So you can write these 3 points for that question. Okay. So next video we will see the current regulated voltage source inverter controller. Okay. Thank you. Okay. So we'll discuss in this video current regulated voltage source controller. Current regulated VSI operation, it which current control PWM. In current controller pulse width modulation, machine phase current is made to flow a sinusoidal response current within a hysteresis band. Sinusoidal reference current IA star is equal to Im sin omega. This is the reference current. The two bands are separated from IA star by an amount uh, delta I as shown in figure. So here we are using the thyristors in diagram, in this block diagram A and B. So here figure A is a current reference voltage, and figure B represents the current regulated VSI. Here we are using the refer current generator and comparator with hysteresis. So and DC supply VSI and induction motor. So each phase current, before going to the induction motor, we are taking the reference, we are giving input to the comparator with hysteresis. So three phases we are giving, and three references currents we will receive, and it will give to the induction give to the voltage source inverter, right. So now we will see the how these thyristors will operate for induction motor. For a voltage source inverter is employed in this inverter, phase A current IA is sharped by transistors TR1 and TR4. When TR1 is on, TR4 is off. Phase A is connected to the positive terminal of DC source, hence the rate of change of current IA will be positive, and when TR4 is on, TR1 is off. Phase A is connected to negative terminal of the DC source. So here we have TR1 and TR4 thyristors we are taking, and so we are converting into negative and positive terminal of DC source. Hence the rate of change of current IA will be negative. So when negative terminal of DC source, automatically the current will be negative. The current IF falls along the path MN, TR4 is on. So IA reaches the lower band at N, TR4 is turned off, TR1 is turned on. So this makes rate of change of IA to be positive, and it rises along the path number when IA reaches the upper band at 0. So TR1 is turned off and TR4 is turned on. So this is how we are controlling the current of the VSI here. So here also we have two things, IB and IC currents. IB and IC currents are IB is equal, IB star is equal to Im sin of omega t minus 120, IC star is equal to Im sin of omega t minus 240. So by controlling the respective transistors IB and IC. So this is about current regulated VSI, right. So this is one of the important one. So you practice this question. Next video we will see the speed control of single phase induction motor. Okay, thank you all.